When programming the IC to operate as a pulse width modulator, pulse width modulators are used to generate pulses at different duty cycles in order to control devices like inverters or servo motors. Now, when programming a programmable IC for that purpose, initially what we must do is when we start our program, we go to other in-out devices, we click on generate pulse width modulator, and we add that. When we double click, we can now see that it brings out our command, and we have to instruct it which is the output pin. We're going to stick with pin 3, and we have to assign a reference or a startup period and duty cycle for the device. Now, you're welcome to click on the pulse width modulator output wizard. That brings up this window over here, and then we can say what is the initial frequency that we want. Let's say it's 1000 Hertz or 1 kilohertz, and we want a 50% duty cycle. When we click calculate, it then shows us that we should have our period set at 294 and our duty cycle set at 499. I'm going to round up, and I'm going to say the period should be 250. That's not working. 250, we scroll down to 250, and the duty cycle we're setting at 500, just to be, there we go. And now we have set our output to operate at 1 kilohertz at a 50% duty cycle. Now it'll operate at that rate irrespective of anything that happens. We want to be able to control, so I'm going to put in a read ADC, in other words read analog to digital converter. When I double click on it, I'm saying I'm using input C1. That's where I'm going to read the data, and I want to store that information in variable A. Once that's done, I'm going to put in another pulse width modulation output. When I double click on it, the input pin is B3. The period I am setting to 100, and then the duty cycle I'm going to set to the value of variable A. When I click OK and I return this back to the input, what's going to happen now is my output pulses is going to change. Well, the duration of each pulse is going to change. The frequency is going to stay the same, and that is then going to be able to control my servo motor or an inverter or whatever the case may be. So when we simulate, press run, we can see it's going through the cycle without any issues, and we can see there that B3 is technically staying on because of the high frequency. If we go to analog, we said our input is C1. So if we go to C1, we see it is at 48 at the moment. So if I decrease it or change it, then we go there to memory, and it shows that the memory value is now 255. So it's reading the input value and switching according to it. If I change that, there I've got 40. If I go to my variables, I can again see I've got variable A set at 40. So it's constantly measuring the input and switching according to the set value of variable A.